I'm Pakistani and watching this from Pakistan. I today this video I will teach how you can make a light following board. So this is part 8 of this video series. First series I assembled this WD potato and then I made ultrasonic optical wired tower. Then I made node MQ based Wi-Fi control tower. Then made slab control tower and then made IR motor control tower and then also made a line following and then made Bluetooth control tower and finally made light following tower. This is a light following tower without arduino, without programming. So first explain over. It's powered by overview. Powered by 5 volt power bank 10,000 mAh. Used to power this. You can use any 5 volt source, rechargeable source you can leave. And I don't have LDR sensor modules, so I have this type of IR sensors with LDRs. I modified these sensors and convert into the LDR sensor by using IR sensor. This experiment I tried in my past video, which is a level security video, but right now in this one, this main add I will remove, so it will made a mistake for handling or what I remove one of this add of the sensor and I solder this LDR, and this one is I not remove that because so it later I need to use IR sensor. I work this sensor IR plus LDR at both same time. Now it's connections. Here we take L298 and motor driver and two motors, L298 and dual motor driver or HV driver. First, USB cable and tip the wire inside. We take 4 wires, green and white wire cut, remaining is contained red and black, which is a positive if that black is negative, which connect ground and pin number ground and motor voltage. This module motor driver app a good feature. It will contain one external pin which is used to power the separate motor power, which contains 5 to 36 volt. It will contain them and power for the motor. This motor is 5 volt motor, so I use 5 volt and ground driven by this USB ground and VCC to motor voltage pin, and their module operates 5 volt. So I also base this 5 volt pin to the motor voltage pin, so it will all operate in the same volt. So and similarly I also connect this ground 5 volt. We also connect these 2 wires also, which these two wires are connected at this row. These 2 wires into this row, backward row. This red wire is positive, or is wire ground. And there are the 2 sensors, which are both are 5 volt is connected to the breadboard, positive rail and negative to negative also connect to common with help of this rail, and this rail negative positive terminal will connect to L298 and motor driver 5 volt or ground terminal. And this sensor output is digital. I use digital output. It comes with analog and digital both output. So I use both sensor digital outputs are connected motor driver. Let's show a motor driver. It will zoom motor driver terminals between middle and pin number 2 and pin number 3, and pin number 1 and pin number 4 are connected to the pull low using a ground terminal of this all common ground, because we normally will tend it's a light following the board. Normally it will 5 volt when apply this, it will directly on the power to a motor driver, and power also comes to this wire and those two both the sensors. But both the sensors by default I set the low sensitivity, meaning it will not detect my room light. When I put the flashlight or torchlight apply these sensors is sense the light and it will output is low. Normally these both sensors output is low. So I already put these two motor driver, two terminals. This contain 4 input and 4 outputs, 2 for one motor and 2 for other motor and outputs, and 4 inputs, which is 2 for one side and 2 for other side. So I put both these channels, one on terminal to pull down the negative rail or ground rail, and another two terminal apply this digital signal which is coming out these sensors. So by default the sensor output is low, and these two wires also pull in the other two pins automatically low. So all these 4 pins is a low pins. Motor drive will not turn on, and it will not rotate motor backward and forward. It will stop the motor because since all the input is low. So once this sensor is detected some source of light greater than its threshold, it will put the output I, both these output I, according to which sensor detects more light, and it will pull the sensor, the motor driver input pins, 2 input pins I, remaining 2 inputs are low, so that's why motor rotates forward direction. This time it will rotate backward direction also, but you need to make sure either rotate forward direction or backward direction, and then wire accordingly. For example, if I put the sensor, by default both the wheels is stopped, sensor right motor will rotate, and if you put the right sensor light, it will rotate a left motor. So if you put both motor at the same time, these days you can use 2 mobile or 2 flashlights in order to do that. But if you then flip this terminals lights, mean if I remove this wire, it will automatically spin, and now spin back. Since I remove the one wire which is one pin is ground, I ground this one pin or pin number 4 to the ground. Middle 2 pins I use as a input signal for output of these 2 sensors. In your case it may be changed. Pin 1 or pin 2 it will work with one direction, or pin 2 or 3 for other direction, or vice versa. So you can connect randomly these 2 terminals. It is not 100% fixed. You can change accordingly these 4 inputs to your requirement, and then requirement to rotate forward or backward wires. Backward. In my case, is the line following the board, so it will follow the light, not though the backward. So you can focus the light, the board goes backward. When you cannot apply light, the board will stop. You can flip this wires individually together. So there are 4 pins total, 2 for each side and 2 for each side. So there's 4 in the 4 pin input pins are randomly placed. So 1 or 2 is one motor control, 2 and 3 is other motor control. So we can flip one ground wire, which is a common ground of a circuit, and one sensor input is nothing between 1 or 2 pin. This time you can flip the polarity. One pin, first net one wire, sensor wire is 1 pin. Direction is not accurate or not correct. You can flip the wire between one pole wire to second pole to first pole, not first pole to third pole, because first second is one side, third fourth is other side. First 2 will be, if both will not work in following direction, it will spin first 2 pins individually and other 2 pins individually, not first 2 pins to the second 2 pins. Otherwise it will not work at all. If you can, there is not losses or never anything is burned in these 4 connections. If you flip wrong way, but it will not it will depending on direction, which direction you need to spin the board. This time you might be see, when I put this hand in the forward, it will spin a wheel, because this sensor have this own I added. I trimmed this sensor add, but not this one, so it will also work with and gesture. It will operate by power of this flashlight. You can use laser light, flashlight, or any fluorescent light. And if you have heat sink, you can put the heat sink on the top of the LDR so it will not fall straight in. So there's a several reasons fall straight in. Level light is a light which is a focus light, but normal LED light is not a focus light. It will flash everywhere. So if one sense is detected, other is automatically detected because there is no distance, too much distance between this one and this one. So that's why if you made this, or you can use some sort of stick, extreme sticks, two sticks, glue here and there and increase the distance between these two sensors, or you can use black etching, not any color etching, only black etching, trim and apply these both two sensors, so it will not fall straight in with other light. Also this experiment drive with level light. Not if you have a level light, it will do the thing, but you can also use with cell phone light or normal LED light. But I recommend you can use this project with level light as the best performance. Now those left world. Now those right world. Now those forward. Now those forward. Left world. Right world. Left world. Forward. Right world. Now those forward. Now those right world. Now those forward. Right, left worlds. Now those forward. Left world. Forward. 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 Left world. Forward. Right world. Forward. Left world. Forward. Forward. Right world. Right world. Right world. Forward. Right world. Forward. Forward. Now those forward. Forward. Now those forward. Now those left world. Now those left world. And right world and right world.